This is the end view of an air-cooled chiller plant with 3 mechanical modules and a full set of auxiliaries. As we pan down the front, we'll see one of the 2 slave modules, and now we're in front of the master mechanical module. In the foreground, we'll see the remote panel, which will be inside the building and connects back to the chiller, giving the operator full control of the air-cooled chiller plant. We pan left and see the pump control cabinet, pan down seeing the glycol feeder and the expansion tank on the left, and the primary and backup chilled water pumps on the base of the unit. We come back up and pan around to see the 160-gallon storage tank and the dual basket strainer. As we pan down, you see the insulated pipe running along the bottom of the lifting frame. That is the bypass line. There are a set of balancing valves that will control the flow of any excess water instead of to the building, back to the storage tank. So the building only receives the precise amount of water that it needs. We've just panned left from the storage tank and the inlet to the dual basket strainer, and we can see the plate and frame heat exchanger. This still shot shows the 2 openings on the right-hand side of that plate and frame heat exchanger. These will be pumped to a second chiller plant, allowing this chiller that we're reviewing now to be a complete backup to that primary source of cooling. We'll now take a view down the back side of this chiller plant, starting with the auxiliaries and the aforementioned heat exchanger, dual basket strainer, and storage tank. The first control box we see is the control panel for the 3 valves associated with the plate and frame heat exchanger, shown here. The next panel is the C1 interface panel. This is the chiller's connection point to the remote panel that we showed on the opposite side of the chiller. In addition, the C1 panel in the upper left-hand corner possesses a step-down transformer, providing a convenience outlet. As we pan into the pump module coming in from the rear, you see the 2 chilled water pumps. One operates as a primary and the other as a backup. This lead lag feature allows either pump to operate in the primary mode. In the background, you can see on the left the green cap on the 5-gallon glycol mini feeder and the red bladder type expansion tank. In the background, you see the plate and frame heat exchanger. As we pan down and move to the left, you can see 2 differential pressure switches adjacent to the pump on the left-hand side. Those provide a redundant proof of flow for switching from the primary pump to a backup if necessary. As we pan to the left, you'll see the headers in the master module, and this stainless steel pipe in the upper portion of the frame follows all the way down the chiller outside and then connects to the rear module. This allows us to isolate the front modules from this rear module. As we look at the single point power junction box end of the chiller, you can see the diagonal pipe running from the upper left to the lower right. That is the bypass line that allows us to operate the rear module while hydronically isolating the front modules. You'll also note a balancing valve on the discharge connection. This, used in conjunction with the bypass line that routes back to the storage tank, allows us to send only the amount of water needed by the building. The rest of the water in this constant volume chiller can be bypassed back to the chilled water storage tank. The final view in the video are the circuit breakers in the single point power junction box. There are 6 circuit breakers, 1 for each mechanical module, 1 for the heat exchanger, 1 for the C1 panel, and 1 for the pump module. In addition to the 6 breakers on the left, on the right hand side you'll note the single point power door interlock disconnect switch circuit breaker.